Okay, let's have the last part of our discussion. We have the graph coloring. Okay, in the mid 1800s, Francis Guthrie was trying to color a map of the counties of England so that it would be easy to distinguish the counties. He wanted the counties sharing a common border to have different colors. After several attempts, he noticed that four colors were required to color the map, but not more than that. Okay, this observation became known as the four color problem. Another map that he explored is the states of the US. Okay, that is colored similarly. So as you notice here in the presentation, note that the map has only four colors and that no two states that share a common border have the same color. Okay, so for this time, we're going to have the concept of the graph coloring under the graph theory, wherein we're going to use it for us to schedule, okay, and to have no overlapping time slots for each schedule that we have. So now we're going to have this concept. For instance, there's a connection between the coloring maps and the graph theory. Okay, this connection has many practical application. And for instance, we have this. Okay, let's say this one is a country, and each portion is considered as a state or a region. Okay, a region for this country. Okay, so let's use the concept of the graph theory for us to represent its colors. Okay, so let's say we use each portion or each region as a vertex, and then if they share a common border, they will have an edge. For instance, we have A and then region B. They are connected because they share a common border. Same with region G. They share a common border, so they are connected. Same goes with B, connected to A, connected to G, to F, to C. Because they share a common border. Okay? And then we have here, let's say for C, it's connected to D, connected to B, connected to F, connected to E. Okay? It shares a common border. So, in short, we have this graph for this country. Okay? We have our representation. Now, we're going to color each vertex wherein they do not have the same color for those regions or those vertex that they have connections. Okay, so let's say A should not be the same with vertex B and vertex G. Same goes with B. It should not be the same with vertex A, vertex G, F, and vertex C. Okay, and if we're going to explore this, we're going to try to identify, we'll have this. Okay, for color green, we'll have region A or vertex A, F, and D. Then for color blue, we'll have region B, vertex B, and vertex E. Then for color pink, we'll have vertex G and vertex C. So if we're going to have its colors, we'll have this. Okay, so as you notice, it's related. Okay, the connection between the coloring maps and graphs has many applications such as the scheduling tasks, designing computers, and even playing Sudoku. Later, we'll try to discuss also, or for another session, we'll have the discussion about answering the Sudoku puzzle and using the graph coloring. Okay. So by definition, we call that as the chromatic number of graphs to identify the minimum number of colors needed to color a graph so that no edge connects vertices of the same color. So I'll give you an example here for us to visualize the concept of graph coloring in scheduling task. Okay, for instance, we have here 5 classes at an elementary school have arranged a tour at a zoo where students get to feed the animals. Okay, so we have this 5 classes, and we need to schedule wherein they need to feed that animals only once a day. Okay, so if the zoo allows animals to be fed only once a day by one class of students, can the tour be accomplished in 2 days? Assume that each class will visit the zoo only on one day. If not, how many days will be required? So as you can see here, we're going to identify the schedule wherein there will be no overlapping of animals that they're going to feed in a day. Okay? So here we're going to have the 5 classes as vertex, and then we're going to connect them if they have the same animal that they're going to feed. Okay, for instance, class number 1 is the same has the same animal with class number 2, which is elephants. And then for class number 1 again, for number 4, class number 4, they have the same animal, which is giraffe. And then for class 1 again, hippos for class number 5. So as you can see, we need to connect class number 1 to class number 2, class number 4, and then class number 5. Class number 2, we're going to connect it with class number 3, of course, and class number 1. Okay, class number 1 because of the elephants. Okay, for class number 3, it's connected with class number 2, of course, and class number 5. Okay, because of the sea lions. Class number 4 will be connected to class number 5 for the polar bears, and then class number 1 for giraffes. Okay, then for last one, class number 5 will be connected to class number 1, of course, for the hippos. Class number 3 for the sea lions, then class number 4 for the polar bears. Okay, so if they're connected already, you don't need to repeat the edge. Okay, so here's the graph of our discussion. So we'll have class number 1 is connected to class number 2, class number 4, and class number 5. Class number 2 is connected with class number 1, class number 3. Class number 3 will be connected to class number 2, class number 5. Then class number 4 will be connected to 1 and 5. Then 5 is connected to 1, 3, and 4. So as you notice here, we'll have connections if they have the same animals to feed. Okay? So here's the graph of this equation. So now, in this case, we're going to identify its schedule, and we're going to have the same color if they don't have connections. For instance, for class number 1, let's say we color it as yellow. So we need to make sure that class number 2, class number 4, and class number 5 is not yellow. Okay, so in this case, only class number 3 will be considered since they don't share a common animal. Then for class number 2, so as you can see, we cannot pick both class number 4 and 5 since they are connected, but we can pick either 4 or 5. So let's say we pick class number 5. Of course, we'll have a separate schedule or separate color for class number 4. Or vice versa. We can have class number 4 as color blue and class number 5 as color green. So we can switch. We have two possible answers. For first day, we'll have class 1 and 3. Class 2 and 5 for second day. And then for third day, class number 4. Or we can switch class number 5 and class number 4 for another possible answer. So as you can see here, it's not possible to do it for 2 days. Okay, the minimum number for the schedule is 3. Okay, the minimum number is 3 days. Okay, so as you notice here, given the situation, all you need to do is to graph this and then use the colors to indicate that they can have the same schedule. To indicate that they have the same schedule. Okay? Let's have another example. Okay, 8 different school clubs want to schedule meetings on the last day of the semester. So they will have their evaluation. Some club members, however, belong to more than one of these clubs. So clubs that share members cannot meet the same time. Okay, they cannot meet at the same time. Okay, so how many different time slots are required to all so that all members can attend all meetings? Okay, clubs that have a member in common are indicated with an X in the table in the next slide. Okay, so if there's an X, it means that they share a common member. Okay, so we'll have this. Okay, so Ski Club share a common member with student government, with honor society, campus Democrats, and campus Republicans. For student government, it shares a common member with Ski Club, Debate Club, honor society, and student newspaper. For Debate Club, it shares with student government, honor society, community outreach, and campus Republicans. For honor society, Ski Club, student government, Debate Club, student newspaper, community outreach, and so on. Okay, so same procedure. From this situation, we're going to have a graph. Okay, we can represent the given information by a graph, and each club is represented by a vertex. So since we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have 8 clubs, so there are 8 vertices here. Okay, and an edge connects two vertices if the corresponding clubs have at least one common member. Okay, if they have the same member. Okay, so I'll present it to you. Okay, their connections. So here's what will happen. Okay, here's the graph of the given table. Again, for instance, Ski Club is connected to Campus Republicans, Campus Democrats, Honor Society, and Student Government since they share a common members. Okay, and Student Government is connected to Ski Club, Student Newspaper, Honor Society, and the Debate Club. Okay, and so on. So we have 8 8 vertices here with connections, and those connections means they share a common member. So again, same procedure. We need to schedule, uh, and also we need to make sure that if we have that color, it should have no connections. If we have the same color, they should have no connections with those clubs. For instance, let's start with Ski Club. Okay, Ski Club. Starting with Ski Club, of course, we're not going to include the Campus Republicans, Campus Democrats, Honor Society, and Student Government. So we need to consider only the Debate Club, Campus, Community Outreach, and Student Newspaper. Okay, so in this case, we can pick Debate Club, and there will be no problem with that since it's not connected with the Ski Club. And then here, if we're going to look at this, it's either community outreach or student newspaper. Because they are connected. Since they are connected and community outreach is also connected with the debate club, of course, we're going to pick the student newspaper. Okay, since debate club is already connected with the community outreach. Okay, and community outreach also is connected with the student newspaper. So we have now one schedule. Okay, if we're going to pick community outreach, debate club and student newspaper should not be included. It's either we pick debate club and student newspaper or we pick the community outreach. Okay, next one. We'll have the campus Republicans. Okay, campus Republicans, it's either we consider campus Democrats, student government, and the honor society. Of course, we're going to pick the campus Democrats since it's not connected to the campus Republicans and student newspaper honor society. Okay, but again, there's a conflict here since student government and honor society is connected. We need to pick one. Okay, we need to be wise for us to have minimum number of schedule or the time slots. So if we're going to pick, let's say, student government, so that's green. Let's say this is green. So that's 2 colors. And then for community outreach and honor society, since they are connected, we need to provide 2 colors for them. So if that's the case, we'll have 4 time slots. Right? So again, if we're going to pick student government, okay, we'll have another 2 colors, one for honor society and one for community outreach, since they are connected. Okay, so if that's the case, let's try another case. Let's say we pick the honor society. If we pick the honor society, there will be no conflict for the student government and community outreach since they are not connected. They can have the same color. Okay, so we'll have the student government and the community outreach. So in this case, we have now 3 time slots compared to 4 time slots earlier. So in this case, we can have the first time slot for ski club, debate club, student newspaper, community outreach, student government for the second time slot, and then campus Republicans, campus Democrats, and honor society for the third time slot. Okay, it could be with different arrangements for the time slots, but make sure the clubs have the same with no connection should be in the same time slot. Okay, in this case we have this one, and this one. This could be the first day, second day, third day, or this could be the first day, second day, and third day, or time slot rather. Okay, so make sure again different colors for having the same connections or same members. Okay, so that's it for the color or the color graph coloring, wherein we determine this time schedule for each clubs in this case. Okay, and then I think I'll discuss separately for the Sudoku puzzle so that you can have its understanding when it comes to their connections. It's your group project actually. Okay.